So my Chromebook ran out of memory, and now we're back in action. But I didn't realize that it had quit before I finished this graph. So what I had ended off, I said, this needs to be a histogram. So the bars are going to be touching. And since we were using the boundaries, the class boundaries, the bars go from tick mark to tick mark. If we were using midpoints, the bars would straddle the midpoints. So what I do is I take my each class boundary section and I make it up to the height of the relative frequency. So the first section was 0.2, the second section was 0.3, and then 0.2 again, 0.13, 0.07, 0.03, and 0.07 again. Okay, the last type of graph that we're going to do in section 2.1 is called an ogive. It's kind of spelled kind of weird, but it's pronounced ogive. And you've probably never heard of one. They're really easy to make, and they have a very specific shape. What it is a cumulative frequency line graph. So what ends up happening is, again, it's a frequency. So you're going to have on this vertical axis is going to be cumulative frequency instead of just frequency. So what ends up happening is that you use your class boundaries along the x-axis, and you start at the lowest with a cumulative frequency of 0 because there's nothing below the lowest class boundary. And then that frequency is always going to go up no matter what. It may go up a little, it may go up a lot, but it's always going to be increasing because it's cumulative. And then at the very last class boundary, the height is going to be the sample space, or n, because it's going to be counting all of the data values. So that's what an ogive looks like. It's always going up and it never goes back down. So cumulative frequency line graph. The graph starts at the lower boundary. Remember, those boundaries are the ones that go 1 decimal place further than the data and always end in 5. At the lower boundary, I didn't want that to be plural, lower boundary of the first class with a frequency of 0. Then the graph ends at the upper boundary of the last class with a frequency of n, which is the sample size. So we're going to create a cumulative frequency graph for our number of GPS units. And this time our vertical axis is going to have to go up a whole lot higher than 10 because our sample size was 30. So we need to at least go up to 30. And along the horizontal axis, we will have our class boundaries. Remember, that's still going to need to be a broken graph or a broken scale there. And since it's using class boundaries, our lowest one was 64.5 and our highest one was 344.5, and they went by 40s. So our first class was from 65 to 104, which means our boundaries go from 64.5 to 104.5. So we'll label this axis down here as price in dollars. And along here we have cumulative frequency. And the units were number of GPS units. Okay. So we had a column for cumulative frequency on our data table. And find that. Cumulative frequency. So of course, at 64.5, the cumulative frequency is going to be 0 because there are no GPS units that were priced below 64.5 or $64.50. Then at or below 104.50, we had 6 units. And then there were 9 in the next class, which means our cumulative frequency would be at 15. And then our next cumulative frequency was 21. I'm going to use a ruler so I get these kind of above where they're supposed to be. And our next cumulative frequency was 25. And then 27. And then 28. And finally we end at 30 because all 30 of them had a price that was $344.50 or below. So we can then connect the dots because this is a line graph. So we want to connect them in straight line segments, not like a smooth curve. And then the way that we can use this graph to read information is if I wanted to know how many GPS units were priced, like maybe I have $264.50 that I can spend. So I can look at my cumulative frequency graph and I can see that at a price point of $264.50, there are 27 units that would fit into that category.